In this video, we are going to understand about some of the terminologies that are basically used when you are training your model practically, right? With the help of Python and sklearn, which we are going to use probably after a couple of sessions. There you'll be seeing this kind of words like training data set, what is test data set, what is validation data set, when do you say when your model is overfitting or underfitting, and with respect to that, what is bias and variance. So in this video, I'm going to cover all the specific topics. Okay, let's consider I have a data set. Okay, let's say that I basically am starting my training. So what I'm going to do is that I will probably have my data set, right? Let's say in this particular data set, I have somewhere around 1,000 data points. Okay, 1,000 data points, irrespective of how many number of features are there, right? And initially, let's say this is my entire data set that I have, and I really need to train some model in this. Okay, train some model, and this model will be able to predict something. Let's say this is a house pricing data set, so I will be having features like size of house, okay, price, size of house, number of bedrooms, okay, and one more feature will be price of the house. Let's say I have this many data points, 1,000 data points with respect to our data, right? Now, this specific data points, initially, whenever you start training your model, the first thing that you really need to do is that try to split this data into two important parts. One is the training data set. One is the something called as training data set. And the other one is something called as test data set. Okay, so what we do over here is that we are trying to split this entire data points between two parts. One is training data set and one is test data set. And let's say that I have taken some ratio like 70 to 30% ratio, 70% to 30% ratio. That basically means my 700 records are over here and my 300 records are over here. Now, why we are specifically doing this specific step, why we are dividing our data into the training data set and test data set. And from this also, we will be able to understand whether our model is overfitting or not. Okay. So this training data set, I will probably use this data for my model to train. Okay. And this test data set, what I will be doing, I'll be using this to test my model. Okay. So for testing the model, I will use this specific data. And this data, once I do the splitting, I'm never going to show this data to my model. Okay. While training, my model will never know about this specific data points. Okay. Now let's take up this training data set. And what is the next step that we do? In our training data set, we do further splitting of this. Now, what kind of splitting we do? We basically divide this into again two parts. Okay. The first part is something called as train, and the second part is something called as validation. Now there is a minute difference between train and validation. Okay. Train part is basically used to train the model. Okay. Train the model, and in the future, whatever practical session we'll be doing, we'll be following the same steps, so that this will give you an idea that how we can identify whether our model is overfitted or not. Similarly, with respect to the validation, why do we use this validation data? We use this for hyperparameter tuning our model. Okay, hyperparameter tuning your model. So if I really want to tune my model, I will basically be using this validation data set. So in short, I will combine train and validation data in order to make our model performance better. Now, when do we face overfitting? When do we face underfitting? That I'm trying to discuss over here. Okay. Now let me go away and let me give some of the scenarios. Obviously, you have seen that I have my train data and my test data. Let's say my model give very good accuracy to the training data. Okay. Let's say this is my model that I'm trying to create. It gives a very good accuracy with respect to the training data and very good accuracy with respect to the test data. Because later on, when we take this test data and predict it, we can basically compare whether it is giving us very good accuracy or not. And this is the model that I specifically want. And this model is basically called as generalized model because it is working well with both train and test data. So this is the generalized model that I specifically want. But let's say that I have a scenario uh, wherein with respect to the training data, I get a very good accuracy. But with respect to the test data, the new test data, I get a bad accuracy. Bad accuracy over here. Let's say that the very good accuracy is somewhere around, I get somewhere around 90%. But in case of bad accuracy, let's say I'm getting somewhere around 50%. Now in this particular scenario, since our model is giving a very good accuracy on the trained data and bad accuracy with respect to the new order test data, we say this condition as our model is overfitting. Our model is overfitting. So when do we say our model is overfitting? When my model has been trained well with the training data set, but with respect to the new data points, it is not able to predict. So because of that, I'm getting a bad accuracy. Okay. So this is a scenario of model is overfitting. Now, whenever I get a good accuracy, we basically say or use a term which is called as low bias. Okay. And since I get a bad accuracy with respect to my test data, I usually use this term which is called as high variance. Okay. High variance. So this is one terminology that we specifically use. Now, let's consider one more scenario. Okay. Now in this scenario, let's say with respect to my training data and with respect to my test data. Okay. Let's say here my model accuracy is low. With respect to the training data, my model accuracy is low. And obviously if my training accuracy is also low, then this model accuracy for the test data will also be low. Right? Now in this scenario, this particular problem statement, I can definitely say my model is overfitting. Sorry, my model is underfitting. Underfitting. So in this basically way, we are just trying to convey that my model is not even trained well with the training data. So if it is not well trained with the training data, obviously it is not going to perform with respect to the test data. So this scenario, we say that my model is underfitting. So in this scenario, I basically use this as high bias and high variance. Okay. We usually use this notation. Okay. And coming to the first situation where I get very good accuracy with respect to the training data and very good accuracy with respect to the test data, I usually say this as, with a simple name, low bias and low variance. And always our aim should be that we should try to always find out this specific generalized model where my training and test accuracy should be good. Let's say if I get my training accuracy as 90%, and if I get my test accuracy as 85%, then I can definitely say that, okay, I'm getting almost similar kind of accuracy with respect to my train and test data itself, right? So this is the basic difference between overfitting and underfitting. And this entire thing, when I'm using bias and variance, here I am specifically saying that, okay, this is also generally called as bias variance trade-off. Okay. Now, if I talk with respect to regression, right? If I try to just draw these points. Okay, let's say this is my this all points that you probably see are my training data points. Okay, now if I try to find out a best fit line, okay, now with respect to this particular best fit line, let's say my new test data is somewhere here. Then obviously you can see that I will be getting almost similar accuracy. So this best fit line will serve or will provide you this specific condition. It will provide you a kind of generalized model. Okay, so this best fit line that I have actually formed, this will basically be giving me good accuracy for the training data also and for the test data also. So this is the generalized model that I specifically want. But if I have some other scenario wherein, let's say this is my model, okay, and let's say, you know, I have the new test data which looks something like this. Let's say over here, over here, over here. And suppose I probably try to create a best fit line. So this is my best fit line. And let's say my new data points is somewhere here. Right? So in this particular case, I know that, see, with respect to this, obviously for the training data set, the accuracy will be high because it has properly fitted this specific model. Right? But with respect to the test data, it is not being able to provide a good solution, because obviously the error is very, very high with respect to the test data. Now in this particular case, this will actually lead to overfitting. Okay. So one assignment that I really want to give you is that just try to find out how underfitting it will be, right? Obviously for the train and the test, the error will be quite high. So whenever I have a generalized model, I can definitely say this as low bias and low variance. And with respect to the overfitting, I can definitely say this is low bias and high variance. Okay. So this is the scenario with respect to overfitting and generalized model. And obviously you can guess about the underfitting part. So this specific thing you really need to understand, because as we go ahead, all the practical part will be implemented in this specific way. And, we'll try to use the R square and adjusted R square in order to find out whether it is overfitting or underfitting. So yes, I hope you liked it. We'll continue the practical part in the next session. Thank you.